Okay, guys, right now we're going over angle of insulation video. I got my man Lil MC helping me on out. Right here. Question 2, explain the angle of insulation. Here's the angle of insulation. Here's the Earth, and here's the equator. When the sun is hitting like this, it's much more direct, all right, versus up in the North Pole or South Pole. When the sun comes in like this, the sunlight gets spread out. That's the angle of insulation, is the angle that the sunlight is hitting the Earth at. For question 3 right here, explain who gets more direct sun rays, a tourist in the Caribbean or an Eskimo in Alaska. So right here's the sun. Sun's rays are coming this way. The Earth is tilted like this, by the way, during the summer months, if this is the northern hemisphere. So you see how the equator gets a lot more sunlight than up here in Alaska? That's because the sun's much more direct here, and up here the sun gets spread out. So who gets more direct sun rays? The tourist in the Caribbean. The Eskimo in Alaska gets more indirect sun rays. They get spread out. How does having a lower angle of insulation keep the temperature from rising? Quite honestly, because like here's the Earth, as the sun hits directly on the Caribbean, that's going to raise the temperature much more because the sun is stronger than up here where the sun hits and it gets spread out. And so the temperature is going to be lower up in the northern hemisphere and lower southern pole. Alright, show how the angle of insolation is different at sunrise, sunset versus noon. That's question 5. So here I am in Connecticut. Sunrise is this way. See how it comes in at a low angle. When the sun is at noon, it's like right above you pretty much, and it's beating down on you. Dude, that's as direct sunlight as you're gonna get. And then as the sun sets over here, the angle is low again. Alright? So it starts out low at sunrise, pretty direct, high at noon, and then low angle again at sunset. Question 6. Show how the sun is different or the same at noon during the winter summer months for the Caribbean in Connecticut. So the sun, here's the Caribbean for you. In the Caribbean, the sun is directly overhead and the seasons don't change. Like so, the sun at noon in July is pretty much in the same location as it is in the winter months if you're in the Caribbean. So if you're in Jamaica and Puerto Rico, the sun at noon is in the same location pretty much every day of the year. Now in Connecticut, because here we are in the summer months, and you're going to see how that's the sun, this is the Earth. You'll see how the sun is basically high up on the horizon. But as we come around here, the wintertime, there's Connecticut now, it's farther away. So the sun is lower on the horizon. Alright, if during the year in Connecticut we receive the same number of daylight hours as Hawaii, why is our temperature lower? So in Connecticut we receive the same number of daylight hours as Hawaii, or in the Caribbean, but again the sun is not as direct up here, so the sun is more spread out. That's why the temperature is lower up here than it is like in Hawaii, which is close to the equator. The sun is more direct. Number 8, show how the temperature increases more rapidly at the Caribbean than it does in Alaska. Same sort of deal. Here's the Caribbean. You see how the sun is coming in? Much more direct. Up here in Alaska, sun gets spread out, all right? I will say the cool thing about Alaska is when it's like this in the northern hemisphere, it's 24 hours of sunlight. Why are you able to look at the sun during sunset but not at noon? I feel bad for this question. This question is kind of fake, all right? You shouldn't be looking at the sun if it's at noon or sunset. That being said, when the sun's right up above you at noon, you're looking down, there's a lot more rays that are a lot more concentrated as they enter your eyeball and into your head. Sunrise, sunset, the rays get spread out more, all right? So it's not as bad for your eyes to be looking straight into the sun because they get more spread out. Still not a good idea though. Where is the sun at equinox compared to the summer solstice and winter solstice? Ooh, this might be the toughest one. So remember how we were talking about how this is the sun, this is the northern hemisphere where like United States is, Europe down here is like Australia, South America, Africa. So right here, this is summertime, okay? Because you see how it's tilted, this green part, a little bit closer to the sun. This is summertime, July, 4th barbecues, swimsuits, that sort of stuff. down in South America, in Australia, they're freezing their buns off, okay, in July. They're not doing cookouts, they're cold. And then what happens is it comes around like this in the orbit. The Earth goes to right here. This is our spring or fall. Actually, this would be our fall. Then over here is going to be our winter months. And you see how now the green top, it's facing away. So this is going to be North America's winter time. So the sun, not as direct. All right. Yeah, and that's going to be winter solstice. And then as it comes around over here, springtime. All right, spring equinox. Describe how the midnight sun happens. Midnight sun happens because if up here is Alaska, you'll see how it rotates like this. The sun can always be seen here. So that's because it's tilted towards the sun. So in July, in Alaska, the sun does not set. Conversely, the problem is if it goes around to the other side, like this, you'll see in December, this thing never gets a look at the sun. So in December, they don't have sunlight for 1 minute of the day even, okay? So that's why for that one. Describe how the sun's rays are concentrated or spread out because of angles of insolation, number 12. That one's a pretty easy one. Sunlight comes in, when it comes in at the equator, it's direct, very concentrated. So it gets up top, it's more spread out, indirect, lower angle of insolation, lower temperature. So that's what we got.